Let's look at the forecast for now. Now we'll go up to the sky deck, and that's where Mish Michaels has a look beyond the forecast. Mish?
Hey, Ken. Today are those tame New England weather days. Of course, we know this isn't always so around these parts. In order to keep tabs on extreme weather, we have thousands of trained volunteer weather spotters dotting the state with a trained eye to the sky, helping to keep tabs on all our crazy weather. We call the program Skywarn. Skywarn coordinators from across the state met in our weather center last night to discuss our common goal, public safety.
The Skywarn program here in Massachusetts is one of the best and most recognized programs in the country.
It's a lot of fun. You get to go out, see the weather, see what goes on.
Jim Palmer is one of thousands of Skywarn spotters across the state, trained by the National Weather Service to report on severe and extreme weather.
A report of a tree down on Maple Street in Danvers. Power lines have come down with it as well.
Hello, National Weather Service.
Reports are sent to the National Weather Service and shared with media outlets like our weather team.
Skywarn spotters in Massachusetts, there are roughly over 4,800 spotters in the region. About 1/3 of those are amateur radio operators.
And those ham operators were instrumental in keeping communication lines open during Hurricane Katrina.
We had 90 knots gusting to 120 knots. Over.
I enjoy volunteering. It's a very satisfying.
That's a good feeling to know that we're helping the general good of the public.
Now, these regular citizens who are armed with a keen weather eye literally volunteer thousands of hours each year keeping tabs on our local weather, and we certainly appreciate their efforts. If you're interested in becoming a Skywarn spotter, free training sessions are now underway across the state. If you'd like to get information on a spot and a time that is convenient for you, visit us online at cbs4boston.com. Live on the CBS 4 Sky Deck, I'm Mish Michaels, CBS 4 News.
Okay, we're going to move on here to the part 2 of the Skywarn session. Now let's going to step back from the meteorology of it a little bit. We'll get back to that, but talk about some communications. Okay? So how do you get weather information? How many people have NOAA Weather Radio or listen to NOAA Weather Radio? Wow.
NOAA Weather Radio.
NOAA Weather Radio.
Patchy.
Yes, okay. And you actually still listen to it. That's good. We have improved the voice, I think, over the years.
Easily rolled NOAA Weather Radio.
All right, now that's not. We're not in that. Don't mean that as a slur to any particular people, but it did sound like it had a particular accent to it. But now it's a. A company called Speechworks in Boston has the contract for the entire National Weather Service, and it's pronouncing, at least we've got it pronouncing the names of the towns and cities a little more properly. Like it doesn't say Falmouth for Falmouth anymore, or Yarmouth, Plymouth, Barnstable.
Or that town next door to New Bedford, Acushnet.
Leominster, there's a good one.
Gloucester?
You think that's bad? There's a county south of Washington, D.C., Fauquier, Fauquier County. There's a little problem with that one. But things are getting better, and NOAA Weather Radio is the only place that will be able to, the only radio that exists that can wake you up at 3 o'clock in the morning with a warning alarm tone and save your life potentially. Okay, if you want it to. It doesn't have to. But in a case where there's a lot of activity going on, you can leave it on, and the alarm will alert you to those features. Now, the more expensive NOAA Weather radios, on the order of $70 or so at your favorite electronics outlet, have what's called the Specific Area Message Encoder, or SAME, and that enables you to program it for, let's say, just your county and the counties upstream, so that once it's gone past you, you don't have to be alerted for that. Or even the most sophisticated ones allow you to program it for the type of warning, so that if you're only interested in tornado warnings and not winter storm warnings, you could do that too. So anyway, it sounds like a lot of you have NOAA Weather radios or know about them. These are the 7 transmitters across our area. In fact, if you're a mariner up in Gloucester, we have a marine-only transmitter now, so that you don't have to hear the land forecasts, and mariners can just hear a more continuous marine broadcast only.
Oh, those are the three original
Oh,
frequencies.
yes.
If you had one of the old weather radios, those are the three you can get. The other four are the ones that were added on in recent years.
Most of the newer weather radios have 7 channels now, and so you can pick up those alternate ones, like the Gloucester one, the next page, that is on 425. You need a 7-channel radio to be able to pick that up. Same thing in Packpanadnock up here. Okay, let's move on. How many people visited our website, weather.gov? Okay, not everybody, so hopefully you'll learn. Very simple website. Once you find it, you'll never want to lose it. It used to be complicated, but now it's just weather.gov/Boston. Okay, if you just forget the Boston part and you go to weather.gov, that'll get you there too. Just get a map of the whole country, click on Massachusetts, and you'll be at weather.gov/Boston. Not weather.com, that's the Weather Channel, private company in Atlanta. Weather.gov is your government tax dollars. And it looks like this, for those of you that have been on it, although lately it's been very green for all the flooding, but watches and warnings are highlighted on the screen. You can click on your particular area and get what's called the point-and-click forecast, which I'll show you in a second. How many people, though, have looked at this down here where it says experimental forecast images? Okay, a few of you. It's not really experimental anymore. It's the real thing. We're producing graphical images. That's the way of the future, is everything graphical. So I'm going to show you that right now. First of all, when you click on the point-and-click, ignore these icons. Okay, they overdo the worst-case scenario because it takes it out of the words of the forecast. So if it's just rain with a slight chance of a thunderstorm, it'll say thunderstorms all day long, like up there. So really need to look at the words. And if you've been looking at the words a little more closely lately, they look a little different, don't they? Like north winds 16 to 18 miles an hour. Is that
we're good.
Is that slicing the bologna a little bit too thin? No, I mean not 15, not 19. 16 to 18. Well, that's because of this gridded graphical data, like I was saying. Anyway, it's much better if I stand right here. Just discovered that. Okay. Anyway, let's move on to the next one there. So here's an example of the gridded forecast. Amazing how much work goes into creating these for every parameter: the temperature, the wind, the dew point, the wave heights. Here's the wave heights. The mariners love this. Every hour out to 10 days. That's what we do all afternoon. And so you can graphically see what's happening. On the next picture here you see warmer in the Connecticut Valley, for example, cooler near the coast. You can actually take your cursor and scroll it across the 8 a.m., 11 a.m., 2 p.m., 5 p.m., every 3-hour increments. Don't even have to click on it, just move it across, and you'll see the map changing for all kinds of different parameters. So for, you can actually see where we're expecting the greatest amounts of rain, for example. Even though the forecast says rain, you can see where it's concentrated if you click on the precipitation map. Okay. Now, in the upper left-hand portion of the mains website thing there's a section called Hazardous Weather Outlooks. If you click on that for southern New England, you'll get our Hazardous Weather Outlook, and we break it into day 1 and days 2 through 7. Anytime we expect a watch, warning, or advisory criteria to be met, we'll be putting it in there. And so this is your very first thing to look for to try to brief yourself on whether your spotter reports might be needed during the week. Now, in this particular example, Mr. Bill has a great sense of humor. See, it's Friday, June 9th, 2006. That's the anniversary of the Worcester tornado. Anyway, tornadoes or large hail are expected across southern New England. And down at the bottom, spotter activation is expected after noon today. We'll try to give you that heads up. Another thing we do is put out a special weather statement, in this case a severe weather outlook, issued, let's say, 5 o'clock in the morning for later in that day, same day. Severe weather possible. parts of the area. We try to tell you when, from 2 p.m. to 8 p.m., and importantly, down at the bottom, Skywarn activation may be required after 2 p.m. That's another clue that you'll have that you may be needed. And another clue is enhanced wording in our forecast, either on the point and click sometimes, or, by the way, if you like the regular wording, the 10 to 15 miles an hour, for example, you can still go back on the left-hand side and under forecasts, click on zone forecast for southern New England, and we still have the regular forecast that we edit and spend a lot of time editing and put in to kind of a little bit more normal words what we're expecting. And but in either case, you may see in some enhanced wording, like thunderstorms may produce large hail and strong winds. That's another clue. May not even say that, just gusty winds and thunderstorms. Anything out of the ordinary wording like that is our clue to you that something may be up more than just the ordinary. By the way, there's special weather statements, or severe weather statements. They scroll across the screen red on the Weather Channel. Does anybody watch the Weather Channel? Okay, put your hands down. Anyway, the Weather Channel is a private company in Atlanta, but they do provide our warnings and watches and statements that scroll red on the screen, but you have to be watching them at the time to see it, right? How about the local forecast on the 8th, accurate and dependable from the Weather Channel? Is that really from the Weather Channel, or is that our forecast in Taunton? Huh? Well, it used to be ours, but about 5 years ago, it became theirs. So anytime you see the local forecast on the Weather Channel, that's their forecast. The only place that you'll see our actual forecast from the Weather Service in Taunton is on the weather radio. Actually, you won't see it, you'll hear it. But on the NOAA Weather Radio and on our webpage. Those are the only places you'll get our forecast.
Gee, I can't tell.
What, you mean NOAA Weather Radio or the webpage? It has the same forecast. Just kidding. Anyway, ours is more accurate for this area. Of course, that's our belief.
We're not exactly biased, are we, Glenn?
No. No, we haven't, you know. We can only speak for our own forecast. So, a severe thunderstorm or tornado watch is issued by the Storm Prediction Center out in Oklahoma, okay, covering large sections of states. And the potential is there for severe weather. When an actual severe weather has been reported by one of you, or we see it imminent on Doppler radar, we issue a warning from the local office out in Taunton. That comes from our office, and the screen scrolls red on the screen, for example. Okay, does everybody understand that? Very important. The difference between a watch and a warning, yes? Yes? One more time. Okay, so you tell me. Which one means, watch out, here it comes? A warning, correct. A warning means, watch out. Okay, that's more serious. A watch means it may happen. Temperature, if it hits 92 today, the atmosphere is going to explode. But it only stays 88, and it's sunny all day long, and it was only a watch. It was just, you know, go about your normal business, but pay particular attention to the sky. A warning means it's happening right now, seek shelter. Okay, got that down. So now we've been talking all through this presentation about the word severe, but we've never actually defined it for you. Okay, so for this, we need to call on two volunteers who haven't been Skywarn trained before. It's very painless. You don't have to come up here or anything. Just raise your hand, and we'll ask you each a question. Okay, this is great, because usually nobody volunteers, and it's going to be till 6 o'clock by the time you get there. And we've got another one all set over there. Great. Okay, here's the first question. Lightning is striking the ground 200 million times per second, burns your house down to the ground, kills your neighbor and their dog.
And you like your neighbor.
Is that a severe thunderstorm by our definition? That's a yes? Final answer? Yes, okay. Well, thank you for trying, but the answer is no. Why the heck not? Didn't I just get finished telling you that lightning is the number 2 weather-related killer in the country? I mean, my God, they were killed. What about, let me just rephrase that. Would I change your answer if I said just one flash of lightning, but it still burned every house down on the street and killed everybody on the street? Or wouldn't it make a difference? I mean, 200 million is a little eccentric there. But, okay. The fact is that even one lightning bolt would not be severe by our definition. Very severe to the people that it strikes, and we're not minimizing how important it is. Lightning is deadly. But what causes thunder? Lightning. It's that heating of the air, 50,000 degrees, that causes that shock wave that Bill talked about before. Okay, so every thunderstorm, therefore, by definition, has lightning. So we would have to warn for every thunderstorm. But that wouldn't be very good because nobody would believe us when the real one came, and because they're capable of producing a tornado or large hail or some damaging winds, things like that. So meteorologically, it's not a good discriminator as to what's severe and what's not severe. So, but we will issue short-term forecasts, special weather statements, things where we see a lot of lightning on our lightning detection system, because it's very dangerous and we need to warn people, but we won't issue a severe thunderstorm warning because lightning is not severe by our definition.
You may see vivid lightning or frequent lightning, but you will not see severe lightning.
But even that, as you'll see later, is not reportable. On the list of things we want you to report, we can tell there's a thunderstorm. Okay, now, here's the next question for this gentleman. Let's say we have 500 inches of rain in 1 hour, and yes, I know, but I changed it to 500.
He's in management.
I'm
He
allowed
can do
to do
that.
whatever I want. No. All right, let's say it's 700 inches. All of southern New England is drowning, and there's no room at the tops of the attics, nothing. And it came from thunderstorms. Is that a severe thunderstorm by our definition?
But that's not the
ding,
question.
ding. Question, though, is it a severe thunderstorm? Yes or no? 5 seconds left. 4, 3. No. That is correct, because we asked trick questions. It'll keep our flash warm. It'll keep our service hydrologist busy for decades, probably her entire career. It'll cause us to issue a flash flood warning pronto, but not a severe thunderstorm, because rainfall is not a criteria either. Okay? Rain is not a criteria, and neither is lightning. How many times on the radio do you hear that, there's all this severe thunderstorm just went through causing flooding on Starro Drive? Okay, but that's really not a severe thunderstorm if flooding is the only thing you're getting. Okay, because rain is not a criteria.
Maybe a thunderstorm with flooding rains, but it is not a severe thunderstorm.
By our definition. And of course, you're being trained to report things to us, so you need to know our definitions and our terminology. How about large hail? Yeah. Damaging winds? Yes. Tornadoes? That counts as damaging winds. Those are all severe. So let's talk about the hail and the wind. Our definition of severe size hail is 3/4 of an inch in diameter, which is, as I said, we like to talk in terms of money. Any U.S. coinage is severe. Okay, not foreign coinage, no half pennies or anything, but a penny is 3/4 of an inch, a nickel 7/8, and on up from there. Now a dime, technically, our headquarters people notified us about this, that is 1/32 of an inch less than a penny. Okay. Now,
somebody had a lot of time on their hands.
So anyway, the thing is, we'll consider a dime-size hail report just as severe as a penny-size hail report. Okay, but actually, as Mr. Bill, let's see, we got a copy right here on your Skywarn identification cards that you'll be getting. Right here, for example, see, we've thought of everything. First of all, it's in a nice plastic cover, and a little keyhole there, if you want to put it there. But at the very bottom, we've got a ruler. So in the middle of a thunderstorm, you can just go out and measure the hail size. And the most important point there is you want to report it in terms of inches instead of objects, because that would be a lot more accurate. Okay. Large hail comes, so you see it's all different shapes and sizes. It's not all concentric, so 1/32 of an inch isn't going to make a big difference. Okay, but you're going to be looking for the largest hailstone and report that to us. Okay. Now, for wind, our definition of severe wind is 58 miles per hour, which comes from 50 nautical miles per hour. You multiply by 1.15 to get 57.5 statute miles per hour. So anyway, 58 miles an hour is enough to knock down trees, power lines, and cause all kinds of other damage. Large limbs we define as 2 inches in diameter, and that would count as severe. Of course, any other damage, roof blown off of a house, for example, or windows blown in, that would be severe. And by definition, all tornadoes are severe. Did we mention the word tornado? Let's get back into the meteorology of it a little bit. Again, this is a black tornado going over freshly plowed soil. This is a tan tornado going over some clay soil or some sandy soil. And the next picture you're going to see is kind of takes us back reminiscent to in the 1960s. There was this famous housing subdivision. Hey, Jack's laundry detergent is stronger than dirt. Yeah, remember that? Anyway, kind of
Complete with debris cloud.
debris cloud, yeah. Okay. All right, let's get back into meteorology a little bit, thinking about tornadoes. Remember, the single cell in the cluster storms, never say never, but if it did occur, it would be under the most mature cell. That's where severe weather would occur, and possibly a tornado. Now remember that north-south echo that suddenly bowed out, causing a bow echo? Straight line winds occur along the axis of the bow. But once in a while there can be a tornado. Okay, in West Brookfield, there was what was called a gustnado on the leading edge, right at the axis of the bow, can cause a little spin-up of a weak F0 or F1 usually tornado right at the apex of the bow right there. Another more common thing that develops sometimes with a bowing out downburst wind, if you hit the bottom of this pen here at 100 miles an hour and the top part, relatively speaking, at 40, it's going to want to rotate counterclockwise, yeah? Whereas on this side, if you hit it at 100, on the north side, it's going to be clockwise, right? But 99.9% of all tornadoes are counterclockwise. So it's not this that does it, it's the north end of the axis of the bow, where sometimes you can get a rotating comma head or a hook echo on the north end of the axis of the bow. North end of the axis of the bow. So let's go back to this bow. Remember, only out in Oklahoma did they actually see it jut out right before their eyes. There's the west to the right of the picture, and east to the left of the picture. We're looking south, right? The axis of the bow is right there. That's where the strongest damaging winds were. But if there was going to be a tornado here, where would it be? Remember, the north end of the axis of the bow. Here's the axis of the bow. Where's the north end? Right where you're standing. This is not a safe place to be. Okay? A tornado could be forming overhead, maybe in here, maybe up in here. The north end of the axis of the bow. You're looking south. The north is right where you're standing. You've got to know these things when you're spotting. Okay. And in a supercell storm, that was a squall line. Supercell, it's going to be on the southwest trailing side of the storm, right? Underneath that rain-free base, that's where the updraft is so strong, and near what we call the updraft-downdraft interface. We haven't actually defined that, but we'll show it to you here. Remember, the updraft is right here, very, very strong. the downdraft over here. By the way, why do we have a rain-free base? What are the two reasons that there's a rain-free base? Just shout it out. The winds aloft are very strong, that's correct. So it's going to blow the rain all the way out over here, keeping the updraft and the downdraft separate. So strong winds aloft, that's one reason. What's the second reason? Yes, the updraft is so strong in itself that nothing can fall through it. So those two reasons is why we have the rain-free base. Very good. Now, the updraft, downdraft interface is somewhere here, in between the two. That's where you'd be most suspicious for something developing. Not out here, these are not even enough cloud over there, and not directly under the updraft, a little bit over toward the rain. So stop me here in this picture, just shout out when you think we might have a possibility of a tornado. Yeah? Anybody else? Very good. This is pretty much where everybody shouted the most, and that is correct. Here's the updraft. This is not enough cloud over here. Looks like a rain-free base. All the heavy rain is out this way. So the updraft, downdraft interface somewhere in there. And underneath the main updraft. Not much anvil here, a lot of anvil over there. So you can see even the slope of this thing showing that it's moving from right to left in this picture. Okay, so therefore this would be the trailing southwest side of the storm after all the rain has occurred. But you're looking here and you don't see anything, but Spotter on the other side of that rain curtain saw this. Okay, so your vantage point makes a big difference too. And here's that same storm as viewed from the southeast. Again, here's all the rain up to the north and east, and looking southwest at the trailing end of the storm. And a wall cloud from which it's descending. So again, just to hit the point one more time real quick, single cell underneath the mature cell, brief strong winds, large hail in the squall line, leading edge of the storm. What cloud feature is that? A shelf cloud. Under the shelf is where you're going to get the big wind gusts, maybe severe levels, and then you've got to wait for the rain, and embedded within the rain might be large hail. Never say never, but possibly a tornado at the leading edge, like a gustnado of the axis of the bow, or on the north side of the axis of the bow. But usually it's straight line winds. And with a supercell storm, rare in New England, but you might get a wind gust at the leading edge of the outflow. We didn't talk about that much. It may or may not be severe. And then the southwest side of the storm near that updraft, downdraft interface. And of course, large hail, any kind of tornado is possible.
Yes, that updraft, downdraft interface. On the downdraft side, the potential is there for the large hail. On the updraft side, tornadoes.
Right. And okay, we look at this next picture. Tornadoes are straight, usually one narrow path as viewed from the air. The waviness in the field indicating rotation, and in this cornfield, if you look closely, everything is blown in toward the center of low pressure. Things like to blow in toward the center. Whereas in a downburst, what comes down spreads out in all directions if there are no strong winds aloft, but usually there's strong winds aloft which caused it in the first place, so you'll see it spreading out in the forward direction like that. So that's how we go out after the fact and try to assess whether it was a downburst and tornado. That's one of the things. In New England, here's the Princeton tornado. Worcester County had gone many years without a tornado, and just like Middlesex County is 20 years now, and sure enough, Mother Nature made up for it on Father's Day of 2001, and a F1 tornado cut path through Princeton, Massachusetts. And the amazing thing is, this is typical New England damage. Most people in the town had no clue that a tornado had just hit their town, because it happened in the forest. But there were two houses that were impacted, and believe it or not, one of them was Skywarn train. Not the house, the people in the house. Okay, and they waited their whole life to report this. And the phone lines were down. Okay, so there's a good reason to have amateur radio. So typical New England damage looks like this. A couple of trees, but look at all the other trees are perfectly standing. So in New England, sometimes it seems like a lot, most times it's not. Next. And we have things like Mount Monadnock in the way. Okay, get obstructions to spotting. We have another big obstruction, and that's called the Atlantic Ocean. Causes a lot of moisture. Does this picture look like anything different from what we've just been describing? This is called a heavy precipitation supercell, because that's what we get out here with all that Atlantic moisture. What's different about this picture? How about the precipitation in the rain-free base? Well, not exactly. The structure is the same as what we've been saying. It is still a rain-free base. But this precipitation is actually, because this whole supercell is rotating, that's what they do, supercells rotate. That's the difference between a single cell and a single cell supercell type of storm. The whole system rotates, and some of this rain out ahead of it gets actually drawn behind it, kind of like a shower curtain. It's called a rain curtain, kind of being wrapped around that entire updraft region. So at this point in time it's here, but at another point in time it's over here. Another point in time it might be right in front of the wall cloud, obscuring your view. Okay, and that's what happened in Great Barrington. Rain and fog obscured it. The Windsor Locks tornado completely obscured the tornado. You see anything like an F4 tornado on the ground right here? Yeah? About right there. Sometimes it obscures your view. Other times there's scud clouds that normally they're not any problems, but they can obscure a real tornado on the ground. You just couldn't see that it was actually causing some stuff being flying up from the ground there out in Sheldonville, which is in Norfolk County, Massachusetts, right in Wrentham area. Now remember, we had a tornado in Wrentham 2 years ago too, so maybe it's Great Barrington and Wrentham that attract the storms. I don't know. Anyway, okay, how about this? The observer noted downward motion. Is this a tornado? Do we have a nice bubbly cauliflower looking thing on the side here? Not really. Kind of just, that in itself would tell you that it's kind of a weaker system. But again, downward motion. If it was a tornado, you'd be seeing some spiraling upward motion. Okay, so this was just a very thick rain shaft. Just a rain shaft. How about this next picture? What are these things called? Moving along with the flow, detached from everything else. Scud clouds, yes. Not reportable, just scud clouds. Outflow from the storm. And the rain behind it is what's causing it. How about up in the anvil level? These things here that are kind of hanging down, we call them what? Very good. Cumulus mammatus clouds. Okay? And they're indicators of severe weather many times, but in and of themselves they're not severe. Doesn't necessarily mean the storm is severe. Again, that's at 25,000 feet. Pilots don't want to fly anywhere close to those things. But this feature here looks like the leading edge of the storm would probably be the shelf cloud, right, on the leading edge of the storm. That's where we're most concerned with active weather occurring. How about this feature, this wedge-shaped feature right here? These are just, these lines here are problems with the photograph. But anyway, what is this wedge-shaped feature called? Okay, the majority of people are saying a shelf cloud. Is it pointing toward or away from the rain? Away from the rain. So you are correct. That is a shelf cloud seen edge on. See, here's the heavy rain coming down here, spreading out, kind of like a snowplow, the rain cooled air, sucking this warm, juicy air up above it and producing this wedge-shaped feature. So it points away from the rain area, shelf cloud. Next one. That would be no. That would be moving from right to left in that picture. Okay, now here we have a stair-stepped appearance of cumulus clouds. And here's the main updraft, right? And heavy rain falling out to the right. Pretty much a rain-free base. And a lowering of the rain-free base attached to the rain-free base. And something coming out there. The observer noted downward motion. And the answer is rain. Just a rain shaft, right? It's in the right place. Just a rain shaft. A very interesting location. How about this one now? Okay, now if this was a supercell storm, let's see what we're looking at. Okay, this is pretty much, since it's close up, we're seeing the underside of the storm. So this is a rain-free base, yeah? And if it was a supercell, here's all the rain out there. Which comes first? The rain. And then the southwest trailing side of the storm is the rain-free updraft part of the base, right? So here's the updraft. Here's the downdraft. And which way would this storm be moving? Right to left, right? Because the first thing that happens is the rain. This would be the end of the storm here. So it's moving from right to left. So here's the updraft, here's the downdraft. So the updraft, downdraft interface would be right about here. And in this case, the observer noted upward spiraling motion. And there's even a little bit of commotion down at the ground. So what do we have here? He's been to this before. No? No? Either that or a very good guess. Here we go. A farmer burning his crops in the field. That is correct. One of the best lookalikes ever filmed. Exactly in the right spot. Just crops burning. So you have to be aware of your surroundings. Got to watch things really closely. So now we've defined severe, but we haven't told you what we want you to report. Now you don't have to write all this down because it's on that blue sheet. Okay? And the reason you're here is we really treasure your reports. But we really treasure them when you stick to what's on the blue sheet. We don't have that many people in our office, and if you call to report there's a thunderstorm at my house, for example, you could be taking somebody off the radar to be watching, to be answering your call. We want you to report any hail. You say, okay, you only have pea size, or actually a quarter inch, because you're going to report it in terms of inches, right? Or an eighth of an inch, or a quarter of an inch. Now, there's only one caveat. Got to have some minimum threshold, because a freshly trained spotter out in western Massachusetts a while ago reported sand-size hail. And further questioning, he said it was the size of a grain of sand. Now, Bill and I haven't heard the end of that in over 10 years now. Anyway, so it has to be, at least 6 grains of sand or something.
Yeah, call it about an eighth of an inch. In fact, that's the best way to do. Instead of choosing objects,
Right.
report it in terms of inches.
Right. Now, you may not think that you may think that you're only getting an eighth-inch hail. That might bother us at the weather office, but quite the contrary, as Bill showed you before, especially with those pulse-type thunderstorms, which happen on a typical afternoon, we could be getting small hail at your location. And if it's a real-time report, we can compare that with the radar and say, oh my goodness, they must be getting golf ball-size hail over there. Or it might prevent us from issuing a warning. We're about to issue it, and you're still only getting quarter-inch size hail, and we hold off on it because it is important to not overwarn. So that's for hail. Now for winds, what's our severe threshold? 58 miles an hour. We want you to report when it gets just below that, like 40 miles an hour. That's more than just a typical 20 or 30 mile an hour gust of wind. When it gets to 40, that's telling us this is a significant thunderstorm. Not severe yet, but getting up there. So if you don't have an anemometer, how do we tell? Well, you can go online and check out, Google the Beaufort scale, which tells you what happens with different winds at different levels. But basically, it's enough to cause the leaves to be knocked off of the trees in the summertime. See some leaves on the ground, or some small twigs. That's about 40 miles an hour. Of course, any trees and power lines down, building damage, we want you to report that. And specify whether they're rotten trees. Sometimes with a big drought, it only takes 45 miles an hour of wind to knock down trees because of the weaker rooting system. Or if there's been excessive amount of rain, same thing, trees come down a little easier. But still, trees down is severe by our definition as well. Tornadoes, funnel clouds, and those bona fide wall clouds that you see on the southwest trailing side of a supercell, whether or not they're rotating, you need to report those too. And rainfall. If you don't have a rain gauge, please don't report rainfall because it's really hard to estimate rainfall. Okay, but if you do have a rain gauge, we want to know about 2 inches or more anytime, or if you get a full inch in an hour. That's an inch an hour. It doesn't mean that it was an inch an hour rate for 15 minutes, and if it had just continued raining for another 45 minutes, I would have had an inch. the full inch in an hour. And of course, if you live near flooding of streams or creeks, had a lot of that lately, on your forms it asks if you live near a stream or creek, if in the event out of the 4,000 spotters or more that we have, we choose to call you at a particular time, whether or not you'll be able to live close enough to it to take a look at it for us. Or if you pass it every day on your way to work, just mark that down, something like that. Please do not, as we said, report severe lightning. Severe things will happen to Bill and I.
Yes. Our lives are in your hands, please.
Well, again, only because it's, our terminology and shows that you didn't understand the training. And again, don't report that there's a thunderstorm at your house, because we can tell that. There's only one exception, which Bill will get into in the wintertime here, is with thunder snow. Thunder and snow. That's the one exception. And have you heard the term marble-sized hail? Again, stay away from objects, but take a look why. A lot of different sized marbles out there, right? Okay, we have some rules that we use. Half an inch report is marble sized by our definition and not severe. Okay, so again, we don't want you to stretch a marble into a dime, for example, and have your report appear on the Weather Channel or in the top of our list, because you've exaggerated it. That's not what spotting is about. We want accurate reporting. And in the summertime, the phone or amateur radio, that's where we want the reports right away, to report that way. But in the wintertime, if you're reporting snowfall, we do have this web-based reporting that you'll see. Send us your spotter report, and you can put your snowfall amounts in as often as you wish, and we are looking at that.
Or if we have a major rainstorm during the warm time of the year, your rainfall amounts can also be entered this way. If it isn't a short fuse, fast response type of report, then this is a handy way to get your report into us.
Okay. I apologize, we're running way behind schedule, but we'll try to make it up. Anyway, here is winter storms, the last segment of the show.
Okay, thank you, Glenn. Winter weather, not as though it happens that frequently here in New England, does it? But it is an important thing for us to be able to tell people about, and so let's talk a little bit about winter weather. Winter weather can bring snow, it can bring ice and send people on a nice trip. It can also bring us interesting things happening to the power grid. It can bring us cold and strong winds, sometimes at the same time, which will lead to a very bitter wind chill. And it can cause coastal flooding, although hopefully nothing that reaches Concord. And it can also cause ice jams on streams, and the ice jams will back the water up upstream, causing flooding there, and then when the ice dams break, all that flooding water goes downstream. Now here in New England, we have some very savvy spotters. They know exactly what to look for. Why do we get such variety in our winter weather? Well, it all depends on the storm tracks that's set up any particular year. A couple of years ago, we had a really fantastic winter, if you like snow. The storms dropped down out of Canada and redeveloped along the southeast coast, moved up the coast, bringing up with them a chunk of tropical moisture, and flung that moisture over the New England area while we had cold air in place. The result being lots of snow. Whereas this past winter, well, we got off to a good start, but then things kind of died on us. The storms, they came out of Canada, but then they swung back north of us and passed to our north and west, keeping us on the warm side of the storm, and also really blocking us from most of the precipitation, which typically is on the north and west sides of these storms. Here's how it looks. Close into the storm, everything's warm, you get rain. As you move back, you get into a transition of maybe some ice, and then into some heavy snow, and then lighter snow back from there. And this gives you an idea how the different precip types start. If it's above freezing all the way from below the cloud to the ground, we get the precip melts, we get rain, and that's what we get at the ground. Some cold air right near the ground, the rain falls, but then it hits that cold air and it freezes on contact, and we get a layer of ice on the ground called freezing rain. Or if the cold layer is deeper, The falling rain has a chance to refreeze into chunks of ice, which are called sleet. Or if the temperature is below freezing all the way, cloud to ground, the precipitation never melts, we get snow. Different terms we have. Snow flurries are just when you have those random flakes floating through the air, not really amounting to much. Snow itself is considered white or translucent ice crystals, and whether it's a light snow or a heavy snow depends on the visibility that falling snow causes. Generally more than 5/8 of a mile visibility, it's light snow. When we get below that, we get into what's called moderate snow, and then below 5/16 of a mile, heavy snow. And here's a term you've probably heard too, blizzard. You need 35-mile-an-hour wind, either sustained or frequent gusts, and at the same time, a visibility below a quarter mile in snow, or maybe just blowing snow, blowing yesterday's snow around. These conditions need to prevail for 3 hours or longer. Now, there used to be a temperature requirement years ago, but that's no longer the case. Mentioning the word blizzard, of course, harkens to our dear departed blizzard of '78, which did interesting things to the transportation grid, and for that matter, gave people lots of time to do all sorts of interesting things. A few other winter terms. Snow squall. Brief burst of heavy snow, often accompanied by strong winds. Winter storm watch, winter storm warning. As just with the tornado watch, tornado warning, basically we're expecting a certain type of severe winter weather, 6 inches in 12 hours, 8 inches in 24, or maybe half an inch of freezing rain. Out far, 24, 36 hours in the future, we would do a watch. As we get closer in, 24 hours or less, we'd go to a warning. And here in this area, first inch is usually about the midpoint of December. Average last inch of snow is right about the first day of spring. And over a 128-year period, we had 23 one-foot snowstorms. That's roughly one every 5 or 6 years. How do you measure snow? Good question. Find a clear, flat, open area away from any trees or buildings or other obstructions. Try to take several measurements around the area, because you may get some drifting or some bare spots, and you want to avoid having your one measurement be in one of those spots. So take several measurements and then take the average value of those several measurements. That should give you a good representative total for what's in the area.
Remember, that's a lot different than for hail. You want to report the highest value. Snow is the average value.
If you're measuring snow, please measure it in tenths of an inch. So if you've got a ruler and it says that you've got 5 1/4 inches, well, please don't report 5.25. Please round that off to 5.3. People often ask, do you have to clear your measuring spot? And the answer is you can if you want to, but that itself is not required. If you do clear the snow, please wait 6 hours between clearings, because what you're measuring really isn't so much the snowfall as much as it is the snow accumulation. You have to give the snow some chance to accumulate. You could, in theory, get the most accurate measurement of snowfall by brushing it off as each flake hits the ground. You'd also get a very inflated total, to say the least. But please, if you do clear the snow, wait 6 hours between cleanings.
That's very important. You can report in between the 6 hours, because we need to know if you're getting a couple inches per hour, but give it the 6 hours before you clear it off. One exception somebody brought up a couple nights ago was if your precipitation changed to rain, for example, permanently, then you should probably take a reading right there as it changed to rain, so that you know how much the snow was before it starts compacting.
Exactly. Report to us, please, when you get your first 2 inches of snow, and then every 2 inches that fall after that. Now, if we get one of these storms that leaves us 30 inches, we're not expecting you to call us 15 times. That might be a little much. In that case, you just use some common sense and update us periodically as the snow is coming down. If you get an inch or more in an hour, one of these heavy bursts of snow that is really bringing the snow down like gangbusters, please let us know about that. Most importantly, once you start calling us with snowfall amounts, please give us a final total at the end of the storm. We archive this information on our website. People do go back years after the fact to look up this information, and we want to be able to have that information both for the media and then archived for the future so that people can get an idea not what the first 3/4 of the storm brought us, but what the entire storm brought us.
And one more note about that, public information statements are what we issue, that's what goes out to the media. Please don't be upset if your report doesn't show up in the public information statement. We get a lot of upset spotters about that because you feel like your thing is not being used, but it is being used. But just so you know, we have 735 towns and cities, individual towns within our county warning area of responsibility in southern New England, 365 of them in Massachusetts alone. And we just can't possibly be the end-all news reporting service of every single town. So we try to give a representative sample. Some towns, sometimes it'll be yours, sometimes it'll be an adjacent town, whatever a representative sample is.
Your information, though, is going to us, and we are using it to verify any warnings that we have. It is being used, whether or not you see it in the public information statement. Please report any snow squalls to us. We can tell the snow is there. We probably can't tell that it's sending cars off the highway. If we have ice, an ice storm, please measure the ice radially. Here's a blade of grass, single blade of grass. Measure it out radially, 1, 2 inches. Do not do a diameter, such as right there, from one side of the ice to the other. Just measure it from whatever the ice was accumulating on out to the edge. Generally, as it starts getting above a 1/4 inch accumulation, please let us know. We'll be warning at 1/2 inch. Also, I mean, this won't happen that much, obviously, but if freezing rain is occurring and there's nothing in the forecast, I know that won't happen, but just give us a friendly call, let us know. Any ice jams and flooding, very handy for us to know about that. Also, and here's that exception on the thunderstorm rule, thunder snow, because thunderstorms, while it's snowing, usually means we're getting a very heavy shower of snow. We could be getting several inches of snow accumulation someplace by that thunderstorm. A place out near Air, Massachusetts, years ago, had a thunderstorm with snow, and they had 8 inches in 1 hour. Also, anytime the precipitation type changes, like from rain to snow or rain to freezing rain, once it makes up its mind how it's going to change to, what it's going to change to, please give us a call, let us know. We've talked a lot about thunderstorms, we've talked a lot about winter storms. What about hurricanes? Well, yeah, they do happen here, Bob and Gloria being certainly examples recently. But as a spotting concern, they are actually covered by the other criteria: heavy rain, strong winds, coastal flooding, etc. So as a spotting concern, they're really not something that's that important for us. If a hurricane is going to strike us, we're going to know about it long before you have anything to spot, unless you're spotting the television screen. So what does that mean for spotters? It means that once the storm moves in, as conditions permit, please report to us rainfall measurements so we can assess flooding potential, or wind, assuming your wind instruments haven't blown away to the next county, or any structural damage or any stream or coastal flooding and what extent that is occurring. And have a nice storm. Now, quick review on thunderstorms, and we're all set. Lightning, it's hot, it's dangerous, don't touch it. Can strike as much as 30 miles outside the storm, so be slow on going back outside. If you hear it, fear it. Is heavy rain considered severe? Yes or no? Correct, it is not. Flash flood material maybe, but not severe. What is severe wind? Okay, one more time. 50 knots, 58 miles an hour, correct. What speed do you report? 40 miles an hour, very good. What is severe hail? 3/4 of an inch. What size do you report? Larger than sand. Yeah, 1/8 of an inch, 1/4 of an inch, 1/2 an inch, in that range, yes. What is a tornado? Funnel on the ground. Well, that's getting there. What is the tornado doing? Okay, I heard the word rotating. Yes, a rotating column of air in contact with the ground, yes. And if it's not contacting the ground, funnel cloud. Very good. Where would you find severe weather in this particular thunderstorm? We talked about the 4 types. Here's one of them. Where would you find the severe weather? Right under. Okay, yeah, under or fairly close to this visible updraft. Okay.
Weak winds aloft, the anvil is circular, so what goes up comes down.
Report all lines in the sky, obviously. Which one is the one you want to be focusing on right now? 3. And how about in 15 minutes? 2. Excellent. How about the severe weather with this particular type of thunderstorm? Where would you find it?
3 words.
3 little words. Under the shelf, right there. That would be right there. Okay, where's the severe weather in this picture? Right in there, the updraft, downdraft interface. What kind of tree damage pattern do we most frequently see in New England? B. Sometimes it seems like a lot, most times it's not. What is this feature? And I don't mean the golden arches. This one right here. Shelf cloud, how do you know? Pointing away from the rain, exactly.
Very good.
Rain, cooled air hitting the ground, racing out. That is a shelf cloud. How about this feature right here? Wall cloud, how do we know? Because I told it, because you said it. Notice it is attached to the, you got a rain-free base, and it is attached to the rain-free base. It is a part of the rain-free base. And actually, if you look closely, kind of faint and blurry, but right in there, you actually have a little
tornado on the
ground. Hopefully they have the warning for it going out. Now, is there anything severe in this particular picture? Is there anything severe in this particular picture? The answer is no. Very good.
Excellent.
Excellent. Our lives are in your hands.
No lightning. That's very good.
No severe lightning. How about this feature right here? What is that? Shelf cloud, yes. Where in the storm will you find it?
Yep, ahead of it.
Ahead. Oh, leading, yes, leading edge. Leading edge of the storm. What kind of weather will you expect with this? Wind, yes. Under the shelf, you get these strong straight line winds, and then followed by that, rain and hail. Now, is it time to cancel that tornado watch yet? Nah, I guess not. Okay. What do you see here in this picture? Scud, yes. Cloud fragment, scud cloud, excellent. Now, I'll give you the answer to this one. This is a shelf cloud. Notice how we've had all these shelf cloud questions, like we're trying to be subliminal or something? In any case, this is a shelf cloud. My question for you is, which way is it moving? Moving left to right or right to left? How many people say left to right? How many people say right to left? How many people want to go home? Okay. The answer, well, what do we got here? We got our rain over here, warm humid air over here. Rain hits the ground, rain-cooled air flows out. It's right to left. So very good. Very good. To report to us anytime, we're going to be giving you some spotter cards in a moment. Those spotter cards have on them an 800 number, which is good in any of the 4 states that our office covers. Even if you're outside of our area of responsibility in those states, it will work. The 800 number you call it, you give the person answering your ID number, your location, and the report of what it is that made you call. Also be sure to let us know about what time that event took place, whether it's right now or 5 minutes ago or 10 minutes ago, and so we can connect it with whatever features we're seeing on the radar. Ham radio operators, you can contact an active weather net and ask them to relay the report to us. It'll come through to the ham radio station in our office. And just a quick overview, a quick review on all these things. Just about any size hail, winds of at least 40 miles an hour or some damage, tornadoes, funnel clouds, wall clouds, and 2 inches or more of rainfall or any flooding. Those are the important things. The overall listing is on that blue sheet. It's also on the back side of your spotter card, so you'll have both of those to refer to, and that's basically it.
One thing I forgot to mention with lightning, of course, you don't want to report just lightning per se, but if after the fact, for example, if you find out that it caused damage, $40,000 of damage to police department computers, for example, or something in your town, that is important. We have a publication called Storm Data, goes through the National Climatic Data Center. It's also on our website, and so we subscribe to newspaper services across the area, but not every one of them. So if you find something out, a week after the fact in the local paper, please let us know about that, because we have 60 days to file that damage report.
Question. How do you report your location? What city or town are you in?
Sure, then.
Well, you can't.
Part of the town would be important too.
Part of the town will help. I mean, if we're in a rush, certainly the city or town will help. If you can narrow it down to even further, that's fine too. That yes, if you're near an exit on the Mass Pike, key it to it on that, or an exit number on 495. Yeah, anything that can pinpoint where you are when you're spotting this phenomenon.
Well, no, we can look it up and see specifically where you are, and then convert that to where it is on the radar. Tell the radar operator immediately. In fact, as soon as we enter all this stuff into the database, the spotter locations are plotted directly on our radar map, so we can actually see exactly where you are with respect to the storm. If you're at your home address.
Yeah, what about, say, a lightning strike that results in fire?
A lightning strike that results in fire. Well, that would be causing damage.
Right, again, damage. Yeah, just if you can report a fire from lightning, that would be important too.
Just don't call it severe lightning when you do so. Okay. Well, if it's a short fuse type thing like a thunderstorm, severe thunderstorm criteria, or even just any hail or wind criteria, giving us a call is probably better. That will be more immediate. Something more long fuse like a rainfall amount or a snowfall amount, the internet is a fine vehicle for that. So it'll depend on the situation. Use your best judgment. How urgently do we need to know the information this minute?
But if a rainfall amount in the case of like extreme flooding like this, I would call on the phone. But 2 inches normally isn't going to cause major flooding like we had. But we still want to know about it, then that's more of an internet thing. Okay, a couple more questions?
Well, you can call in on the 800 number from Massachusetts, Rhode Island, Connecticut, or New Hampshire.
I believe that's the only 4 states it'll work in.
Yeah, Vermont and Maine, it won't work. But like if you're in Concord, New Hampshire, or in Bridgeport, Connecticut, I believe the number will work because you're in one of the 4 states.
Even though that's not our area of responsibility, you can call it into us and we can notify the other office. Okay, well, we really appreciate your coming, and we have this down to a science. Outside here, in about 1 minute, we're going to set up 2 different sides of the desk.